Welcome to this channel named Mathematics Made Easy. Today our focus is going to be on trigonometric ratios. The names of the 6 trigonometric functions are the sine, we have the sine here, the cosine, the tangent, and we have the cosecant, we have the secant, and the cotangent. Now, the names of all these 6 functions have 3-lettered abbreviations as shown in the table below. So let's look at the table. We have sine here. Now, this is how normally we use to represent the sine, this ratio, the sine. We have cosine as cos, we have tangent as what? Tan. We have secant as what? We have the cosecant as what? The cosec. Then we have the secant as the sec, and we have the cotangent as the cot. Now the first 3 here, we have the first 3 here, and the last 3 becomes the reciprocals of the first 3. Alright, so except for cosecant, all abbreviations are the first 3 letters of the names. So except this one, the cosecant. The last 3 are simply the reciprocals of the first 3, as I mentioned earlier. So the last 3 here, we have the cosecant, the sec, and the cot. They are the reciprocals of the first 3 here. Okay, then also the last, remember that the reciprocals of something like 2 could be 1 on 2. Yes, that is a reciprocal. So the same thing, if you have A on B, its reciprocal will be B on A. Alright, so this is the same as in that reciprocal of sine is the cosecant. Let's look at the table below, table 2, the reciprocals of the 3 trigonometric ratios. We have sine with the reciprocal being what? Cosecant. We have cosine with the reciprocal being what? Secant. We have the tangent with the reciprocal being what? The cotangent. Normally the cotangent is what? What? Cot. Okay. So this means that if I have cosecant, it can be written as what? 1 on sine. So 1 on sine is what? Cosecant. We have the secant, which is 1 on cos. So this secant here is the reciprocal of what? The cosine. We have the cotangent, which is equal to what? 1 on what? Tangent. Yes, or 1 on tan. All possible ratios of the 3 sides of a right angle triangle give the trigonometric ratios. Let us generate a right angle triangle, or we use the right angle triangle to generate the ratios. Alright, so we are going to draw a right angle triangle. Now this is a right angle triangle. We said a right angle triangle has it's a type of triangle with one of its angle measured exactly what? 90 degrees. Now this angle here is 90 degrees. Now we have an angle here named theta. Now the side, the longest side, which is opposite to the angle, the 90 degrees here, is called the hypotenuse. Now the adjacent and the opposite is determined by where you place your angle. If the angle is placed here, where it faces becomes the opposite and this side becomes the adjacent. Since the angle is being placed here, it faces this place. So this becomes what? The opposite. So this is going to be its what? Adjacent. Alright, so that is how it is. Now we are to look at the ratios. Now the sine of this angle will be equal to what? Opposite on what? The hypotenuse. Now basically we use this ones here, so this can help us to easily get them. So ka toa, so ka toa. All right, so with the so ka toa here, the first one, S here represents what? Sine, which is equal to O, which is opposite on what? H, which is what? The hypotenuse. So sine is equal to opposite on what? Hypotenuse. So that is for the sine. Now, ka here, we are going for the cos. C here is the cos. A represents the adjacent, then divided by what? Hypotenuse. So the cos is equal to adjacent on what? Hypotenuse. Then we have tan. So tan of the angle will be equal to what? The opposite on what? Adjacent. So T here is tan. This is T, tan. Then O is opposite and A is what? Adjacent. So that's one. That will be equal to what? The opposite on what? Adjacent. Now the last three will be the reciprocals of what? The first three. Now we have cosecant. Cosecant. This is the opposite of the sine. So since sine is opposite on hypotenuse, then cosecant theta will be what? The hypotenuse on what? Opposite. Yes. Now we have cos. Then sec here is the opposite of what? This is the reciprocal of what? The cos. So we have sec here. Now sec, we have cos being adjacent on hypotenuse, so the sec will be the hypotenuse on adjacent. Then we have the tan being the opposite of what? The tangent. Opposite of what? The tangent. So this cos, the cot is the opposite of what? The tan. So tan is opposite on adjacent, so cot will be what? Adjacent on opposite. Simple as that. Alright, so let's note some properties here. The trigonometric functions are properties of angles, not triangles. So we use the triangles to help find the ratios. We use the triangle to help do what? Find the ratios. Then also, the trigonometric functions have no units. So let's note that. The square trigonometric functions, for example, are written as this and are read as what? Cos squared theta. If it is cos squared, let's say any letter representing the angle, we say cos squared that particular angle. Let's say alpha, cos squared alpha, cos squared A, and that is that. So in our next video, we're going to look at how to solve problems or with this concept that we just looked at. Thank you for watching.